This lesson is for day 9. We're going to be writing exponential equations. We have two different objectives for the day. One is to calculate two larger and two smaller values in a given table for an exponential function. So this time we are going to tell you that it's an exponential function. We're going to give you a few points that lie on that exponential function and then have you calculate additional points. And then your second objective is to be just given a table. You're going to write the exponential equation that matches that table. So here I've got the general form for an exponential function. We've got two different forms that we've seen so far. Y equals a times b to the x, or y equals a times 1 plus or minus r to the x. Now this one is typically used for model problems, so we're really going to focus on this one for today. Okay, so this is a bit strange, but I'm actually going to go back to our day 7 notes where we graphed exponential functions. So if you look at the table from the first graph that we looked at, this was y equals 3 to the x. Now this is an exponential growth, and here are my table values. Now there's a pattern when you look at exponential functions tables. In your x column, you're going to see the same number being added, so it's increasing by 1 to get from one x value to the next. Now in your y values though, as you go down in this table, I'm actually looking for a number that multiplies to get from one number to the next. Now here, I see that I have a pattern. If I multiply each of these values by 3, I get to the next value. So 1/3 times 3 gives me 1, 1 times 3 gives me 3, and so on. So the difference here between your values is a factor of 3, a multiplier of 3. Okay? Now I'm going to go to the next graph that we did that was a decay. So this is y equals 1/4 to the x. Now this is a decay, an exponential decay, but if you look at your x values, these are still increasing by the same amount. I'm adding 1 to each of these values in order to get to the next x value. My y's though, this time, I'm looking at the pattern here and I see, oh, 16 to get to 4, I'm dividing by 4. To get from 4 to 1, I'm dividing by 4. Dividing by 4 is the same as multiplying by 1/4. So it's not really a coincidence here that we're seeing that multiplier 1/4 here as well. But if I multiply by 1/4 on each of the y values, I get the next x value. So when we come back to our notes, that's what we're going to be looking for. Okay, so problems 1 and 2 here are our first objective. We're supposed to calculate two larger and two smaller values of x in the given table for an exponential function. So instead of giving you all the values, we're actually asking you to come up with some missing values. Now remember, we have a pattern that we can follow. We know that in the x values, they're going to increase by the same amount, and in the y values, we're looking for a multiplier. So you're going to answer two questions. What is the change in x? Now, to get from 3 to 8, I would have to add 5. That means that in this column here, I can add 5, and then add 5 again to get my two larger values. To get my smaller values, I'd have to subtract 5. So I would still be, from -2 to 3, I'd still be adding a 5 here, but to actually get this number, this -2, I need to subtract 3, 3 minus 5. So now I do -2 minus 5, and I get -7. So it's still consistent. We'd still be adding 5 to get to the next value. Now the second question is, what is the change in the y value? To get from 1/5 to 1, I would have to multiply by a factor of 5 to get from 1/5 to 1, right? So to get from 1 to the next number, I'm also going to multiply by 5. So I would get a 5 here. Multiply by 5 again, and I get 25. Now, to go backwards, you're actually going to have to divide by 5. So to get from this 1/5 to the number preceding that, I would have to divide this by 5. So 1/5 divided by 5 is the same as multiplying by the reciprocal of 1/5. So I end up with 1/25. Now I'm going to do the same thing to get from 1/25 to the number preceding that. I want to multiply by 1/5 because it's the same as dividing by 5. So I would get 1/125. Alright, so that's how we calculate. I'm going to erase all the stuff that's not really that important here. That's how we calculate two smaller values. So here were the smaller values that are points on this exponential growth table here, as well as these values that are larger. Okay, let's try problem 2. Okay, now in problem 2, you're going to ask yourself the same exact questions. What's the change in x? What's the change in y? Now for the change in x, to get from -3 to -1, I would have to add 2. So I'm going to continue to add 2 here. So I would get a positive 1, then add 2 to 1, and I get 3. Now to get the x values that are smaller, I'm going to subtract 2. So I would get -5, subtract 2 again, and I get -7. Now, the change in the y value, you can think of this as two different things. To get from 1/9 to 1/81, really I'm dividing by 9. I like to look at this, though, as a multiplier, so I'm going to change that into multiplying by 1/9. Okay, so I'm multiplying by 1/9 to get to 1/81. So now I have to multiply by 1/9 again to get to the next value, which is going to be 1/729. I'm going to multiply again by 1/9. Now, I don't have you guys memorizing 9 to the 4th power, but it's really easy just to do 729 times 9. So that's not really too hard, but this is 1/6561. Okay? Now, to go backwards, this is where you have to divide by 1/9. So you're taking this value here, and we're dividing by 1/9. Now, to divide by 1/9 is the same as multiplying by 9. So we're taking that value now, and we would get a 1 here. Now, to go backwards again, we would divide by 1/9, right, to get to the one above it. Well, I'm going to multiply then by 9 to get a value of 9. And just always double check that your values change at the same factor. So let me erase this. And here's a way you can double check if your table of values are correct. To get from 9 to 1, I'd have to multiply by 1/9. To get from 1 to 1/9, I'd have to multiply by 1/9. To get from 1/9 to 1/81, I'd have to multiply by 1/9. So I am seeing a consistency here in my y values. So this last question, number 3, is still the first objective. It's just like questions 1 and 2, except for the data is given to you a little bit differently. It's given to you in function notation. So remember that f of x is equal to y. So here, these values inside your parentheses just represent the x values. These are your y values. So you can go ahead and make a table if you need to. So here's my x, y. I'm going to use 1, 50 and 3, 20 as my x values. And then I go ahead and work on this problem the same way as I did the other two. I'm going to look at the x values, and since I'm adding 2 here, I continue to add 2 to the x column, and then I'm going to subtract 2 to the x column to get the preceding values. So that would be -1 and -3. Now, for the y, the change in the y, this might not be something that jumps out at you right away. This factor is actually 2/5. Now, I can see what that is, but it might not be something that pops out at you right away. So to figure out what that value is, all you actually have to do is take this value and divide it by the preceding value. So you're going to take 20 divided by 50 in order to get 2/5. So that would be the multiplier here. Now, just to explain why this works, I'm going to go back to the table right beforehand. So let's say I'm looking at, let's even work on these 2 points. Okay, to get from 5 to 25, obviously we all know that that's just a multiple of 5, right? But let's say you didn't know that. The same way that you're going to use the logic here to divide 20 divided by 50, you could take 25, this number here, and divide it by the preceding value to figure out what was originally multiplied by. So 5 had to be multiplied by 5 in order to get to 25. Okay, that's the same logic here that you would use. Obviously this one's a little bit easier to see just because we're used to those numbers. But basically whenever you get a value that's harder to see, you're just going to take this number and divide it by the preceding value. Okay? Alright, so we're multiplying by a factor of 2/5, which means that my next value here, I'm going to take 20 and multiply that by 2/5 to get the next value in this table. And let's change colors here. So this, I can simplify that and make that 4 times 2, which is going to give me 8. So now I take 8 and I multiply it again by 2/5, and I get 16/5. So I have the coordinate 7, 16/5. Now to work backwards, remember, to work backwards, you're really dividing now by 2/5. So I would want to take 50, and I want to divide by 2/5. So 50 divided by 2/5 is the same as 50 multiplied by 5/2. So I get 250 over 2. Actually, I could have simplified this really quickly, actually. 2 goes into 50 25 times. 25 times 5 is 125. So the point prior to that was -125. And then again, to get from this value to the previous one, I'm going to take 125 now and divide by 2/5, which is the same as taking 125, multiplying it by its reciprocal, 5/2. This one isn't going to simplify so nicely for me, but this is going to be 625 divided by 2. And there's my table. Okay, now our second objective for today is to write equations of exponential functions. Now this is really just building on a skill that you guys already have. Remember, before we studied linear functions as well as quadratic functions. Today we're just extending that to writing exponential functions. Now an exponential function is in the form y equals a times b to the x. The a value is your initial value. It is your y-intercept. Okay? Your b value is the multiplier that you're going to see in your y column. Now, let's talk about how you can find the a and the b value. Okay, here I have an exponential growth and an exponential decay table along with the equations that relate the data in those tables. Now, when you're looking for your function y equals a times b to the x, you want to look for your y-intercept first. Here I have a y-intercept of 2, which is why in this function I see that I have y equals 2 times, here the multiplier is 3. Over here I see the y-intercept is 2, so I'm also consistent with y equals 2 times some multiplier to the x. Okay, it's matching up here. Now when I look for the multiplier, what we typically look for is the value that changes from the y's, right? So it looks like here my multiplier is 9. To get from 2/9 to 2, I'd have to multiply by 9. To get from 2 to 18, I'd have to multiply by 9. So it looks like in this case, the multiplier, my b value, is 9. But when I look back up here, it's actually not consistent. So there's something wrong here with assuming that my multiplier is 9. Over here, same thing. It looks like my multiplier here is 1/9. To get from 18 to 2, I'd have to multiply by 1/9. To get from 2 to 2/9, I'd have to multiply by 1/9. But that doesn't actually match up with my multiplier here, which is 1/3. The reason for this is because my data table's x values do not increase by 1. Now if I come down here, it's the same exact function, but the data tables have been filled in so that they increase by 1. Okay, each one of these increases by 1. Now you're going to see that your multiplier 3 is consistent. It matches up to here. This is the exact same function, just different values, right? I have the point 4162 here. I'm missing that point here. I'm also including -1 and 1 here, where over here I skip those values. So you have to be really careful about assuming what your multiplier is. It won't work if your multiplier, or I'm sorry, if your x values don't increase by 1. When they do, you can assume that your b value is this value here, and you can plug that right in. Over here, same thing. See how these are increasing by 1? My multiplier here, 1/3, is the multiplier that defines this function as well. Okay, so let's practice, and we'll begin with problem number 4 here. I do want you to write this down real quick here and plug in what you know. Remember, your a value is your initial value. It's called the y-intercept in this case. And your b value is your multiplier. So make sure you write that down on your notes. Okay, so let's begin here. The first thing I want to check in problem 4 is that my x values increase by 1. Since they do, I can assume then that my multiplier here, which happens to be 2, right? To get from 3 to 6, I multiply by 2. From 6 to 12, multiply by 2. Then I can assume that that multiplier is correct. The b value here is 2. I'm also looking for my a value, the y-intercept. I can spot that right away in the table. The y-intercept here is 3. So therefore, in my equation, this is really, really easy for me. This is just going to be y equals 3 times 2 to the x. So this is the equation for this data table here. Okay, let's begin with number 5 here. Now in number 5, the first thing that pops out to me is the fact that there is no y-intercept. Okay, now because there's no y-intercept, you can do one of two things. You can find it, and that wouldn't be too hard here because it's only one value smaller. Right? If we want to go backwards, that's just like our first skill, our first objective that we are working on, problems 1 through 3. I'm not going to do that with you though. Instead, I'm going to look at the fact that since this is increasing by 1, I can use my multiplier. My multiplier here is what I want to find. Okay? Now, this isn't going to pop out quite as easily at you because the numbers are a little bit goofy here, but remember, to find that multiplier, you take one value and divide it by the number that's preceding that. So we take 80 divided by 100. This is going to simplify to 4/5. So my multiplier here is 4/5. So b is 4/5. And now I'm going to plug in what I know into y equals a times b to the x. So I end up with y equals a times 4/5 to the x power. Now, all I have left to do is find the a value. Now, like I said, I'm not going to find the actual y-intercept by going backwards, even though that would actually be easier here because I want to work on the skill that you're going to be using for the rest of these problems. Now, notice you have an x and a y here. This is any coordinate, which means that any coordinate here should satisfy this equation. So I can plug in this xy pair or this xy pair into my function here and solve for the a. So that's what I'm going to do here. I don't care which point you use. I'm going to use the point 1, 100. So by plugging in the values 1, 100 for x and y, I end up with the equation 100 equals a times 4/5 to the first power is just going to be 4/5, right? And now I'm solving 4/5 times a equals 100. To get a by itself, I multiply by the reciprocal, 5/4. Canceling here, this goes in 25 times. I end up with 125. So my equation then, once I plug the a value back into here, is y equals 125 times 4/5 to the x power. Okay, I'm going to let you guys work on number 6 on your own. These aren't really that easy to do, so please make sure you get the practice and check with the key. Number 6 is similar to number 5, so I'm going to skip that one and move on to 7. Now in number 7, the first thing that pops out at me is the fact that I do have my y-intercept here. So in y equals a times b to the x, I already know the a value is going to be 16. So I have y equals 16 times b to the x. Now in this case, I notice that my x values do not increase by 1, they increase by 2. So that means that the multiplier here, which I thought would have been 4, right? 4 times 16, or 4 times 4 gives me 16. That's actually not the correct multiplier. So I cannot use 4 as my b value. So make sure b is not 4. Okay, a lot of people will incorrectly do that and write your equation using the 4. So what I have to do now is take this general form, y equals 16 times b to the x, and plug in an xy value, just like we did in the last problem that I worked on with you. So you're going to plug in an xy pair. Now, it's usually pretty easy to use values that are one positive. I wouldn't use an x value that's negative because you're going to have to plug in that value here, leaving you with the reciprocal 1 over b squared, in this case if you plugged in -2, which I wouldn't do. So I usually don't use the negative values. You could, but it just makes it harder on yourself. I also don't get extremely large, like 6. If you plugged in 6, 1024, you get 1024 equals 16 times b to the 6th power. That's not something that I want you guys to work on quite yet, so instead I'm going to pick the smallest value here, the 264. You cannot reuse the y-intercept, so you're going to use another coordinate, 264. So that's the point that I'm going to choose to plug in. Okay. Now if I plug in 2 comma 64, I get 64 equals 16 times b to the 2nd power. So I'm solving 64 equals 16 times b squared. To solve for b, I would divide out that 16. So I have 4 equals b squared. Square root that, and I do get 2 possible values. One is +2, one is -2. Now obviously the b value is not -2 because then these values here would not be positive. So you're going to throw out that negative. B is 2, so we end up with y equals 16 times 2 to the x. Okay? Okay, last up in problem number 8, I see that I do have a y-intercept here. So in my general function, y equals a times b to the x, my a value is 3, so I can go ahead and plug that in. I have y equals 3 times b to the x. Now, I notice that these values here increase by 2, so because they don't increase by 1, I can't just look over at the y table for the multiplier. Instead, I have to plug in an xy pair. Okay. Now when choosing that xy pair, remember, don't use the negative values, they just make it a little bit trickier. Instead of using the largest value, I'm going to use the smallest value I possibly can, which is this point 29. So I'm going to use 29 and go ahead and plug that in. So I end up with the equation 9 equals 3 times b to the 2nd power. So I'm going to erase those parentheses now and write that as just b squared. So this is a pretty easy equation to solve. I end up with 3 equaling b squared. And when I square root both sides here, I get positive or negative root 3. I'm going to cancel out, or I'm sorry, ignore the negative root 3, so I end up with b equaling just root 3. Okay, and then I'm going to plug that back into the original general form here, so that I end up with the equation y equals 3 times the square root of 3 to the x power. So this is the final answer here for question number 8. Alright, that's the end of the lesson. You will work on some trickier ones tomorrow. Make sure that you're prepared, ready to come to class asking any questions that you still might have. Nice job. I'll see you tomorrow.